Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is combinational logic circuits. On completion, the students will be able to define combinational and sequential logic circuits and explain the concept of bubble pushing and be able to draw schematic diagram and symbol diagram for different gates and combinational circuits. CMOS logic. Digital logics are divided into combinational and sequential circuits. Combinational circuits are circuits where the outputs depend only on the present input values. And for sequential or regenerative circuit, the output is not only a function of the present input but it also depends on the previous input signals. And as a result, a sequential circuit includes both a combinational logic portion and also a memory module. Examples are registers, counters, and memory. The building blocks for combinational circuits are basically logic gates, while in the case of sequential circuits, the building blocks are latches and registers. The delay of a logic gate depends on its output current I, load capacitance C, and also the output voltage swing del V. And alternative CMOS logic configurations include the ratioed circuits, dynamic circuits, as well as pass transistor circuits. All together form the circuit families. NMOS transistors generally provide more current than PMOS for the same size and capacitance value, and hence NMOS networks are more preferable. The diagram represents a combinational logic circuit with 3 inputs and 2 outputs, and similarly the same can be modified as a sequential circuit, additionally providing a memory or a state block. Examples of combinational circuits. A CMOS inverter. Here we can see a CMOS inverter and its schematic and symbol diagram. And here we are giving A as input and Y is the output obtained. And we have a pair of MOS transistors. One is a PMOS and other one is an NMOS. The PMOS is linking the output to the supply voltage, whereas the NMOS is connecting it towards the ground. This is the diagrammatic representation of a 2-input NAND gate where 2 PMOS transistors are parallelly connected and 2 NMOS transistors are seriously connected. Similarly, for a 2-input NOR gate, we have 2 PMOS transistors seriously connected with 2 NMOS transistors parallelly connected. And A, B are the input and Y is the output taken. We can sketch any combinational logic as with a CMOS implementation, and here Y is given as A plus B plus C into D the whole bar, where we are using 4 pairs of transistors, that is 4 PMOS and 4 NMOS transistors are being implemented, where the PMOS transistors A, B and C are seriously connected representing the OR combination, and it is parallelly connected to D transistor which represents the AND combination. Similarly, at the NMOS side, A, B and C are parallelly connected and it is seriously connected with the D transistor. So from this we can understand the PMOS transistors, a series combination represents an OR operation and parallel combination represents AND operation. Similarly, for NMOS transistors, series combination represents AND operation and parallel combination of transistors represents an OR operation. So this diagram represents the PMOS and NMOS as pull-up and pull-down network. Pull-up network pulls the high output towards the supply voltage, thereby indicating the output as 1. And similarly, the pull-down network, when the NMOS is on and PMOS is off, it pulls down the output towards the ground, indicating the output as low. So series combination of NMOS indicating A into BA or AND B, and parallel combination of NMOS indicating A or B are given here. The diagram represents the concept of bubble pushing. So here we are having a 2-input NOR gate. It is converted into an we can design a two-input NOR gate with the AND gate using two bubbles at both the inputs. Same way, we can obtain a two-input NAND gate from a OR gate by using bubbles at the input. Similarly, we can obtain two-input AND gate as well as OR gate from NOR and NAND gates respectively by following the concept of bubble pushing. Quiz questions on combinational logic circuits. Draw the schematic and symbol for two-input NOR and NAND gates. How do we change a two-input OR gate into a two-input NAND gate using bubble pushing technique? Thank you.